Hello, everyone. Welcome back to PamTen's YouTube channel. And in today's session, we'll learn about linked lists and implement linked lists with Python. So, linked list is a very common and popular data structure. And if you want to start off by learning data structures and algorithms, this is a data structure which you should definitely know. So a linked list, the smallest building block in a linked list is known as a node, and a node comprises of two things, a value and a pointer to the next node. So for that, we'll go ahead and create a class for this node. So I'll write in the keyword class, and by convention, you will always keep the first letter of a class in capital letters. So I'll name it as list node, and then I'll create a constructor. So a constructor is a special type of method in Python with the help of which we can directly instantiate values. So here, if we are creating any method inside a class, your first parameter will always be self, and then we can pass in other parameters. So this method takes in one parameter apart from self, which is val, and here this node will have a value, and that is what I'm setting over here. Apart from that, I also told you that a node will also have a next pointer. So initially, this is just the template of a node. So I'll set the next pointer to be equal to none. So we have created a node class. Now we'll go ahead and create a template for our linked list. So I'll say class of linked list, and with the help of this class, what we'll do is we'll be able to traverse the linked list, insert something at the head of the linked list, and insert something at the tail of a linked list. So head is a pointer which points to the starting node of a linked list, and tail is another pointer which will point to the last node of a linked list. So here I'll start off by creating again a constructor. I'll say def init, and inside this there'll just be self. I'll create head. So self dot head is equal to none, and then after this, let me write this method properly. So you'd have to give in two underscores before init and after init. I've created the init method or the constructor. Then I'll go ahead and create a method to traverse the linked list. So I'll say def of traverse. This has the self parameter, which is something which we'll definitely need. And then what I'd want to do is I'd want to traverse the linked list. So I'll take in a temporary node, I'll call it as temp, and I'll just point it to the head as of now. And what I want to do is I want to travel this. So while temp dot next is not equal to none. So I'll keep on traveling till I reach the last node. So let's say if I have three nodes, 10, 20, and 30, then 30's next pointer will point to none. So if that is the case, then temp will be pointing to 30. So I'll keep on incrementing the value of temp till it reaches the last node. So temp is equal to temp dot next. And when I've reached the last node, what I also want to do is so I have reached the last node, and I'd want to keep printing the value since I'm actually traversing here. So I would want to actually go till the last node and keep printing the value. So I'll say while temp is not equal to none, print temp dot val. So let's see if I have 10, 20, and 30. I'll print 10, go to the next one. Print 20, go to the next one. Print 30, go to the next one. And then finally, 30's next will be none, and I'll come out of this. So this is how I'll be able to traverse. Now, I would want to also create another method to insert something at the head of a linked list. So I'll say def insert at head. Apart from self, I'll take in another parameter to give in the value. Here I'll take in a new node. So I'll say new node is equal to list node, and I'll pass in the value. So here what you see, this is the class list node, and I'm creating an instance of it called as new node. So here whatever value we pass, so here we're passing it that value and we're storing it in new node. So we've created this new node. Now I'd want to check if is there a head present or not. So if self.head is equal to none, which would mean that there is no node as of now. If that is the case, what I can do is I can just point head to the new node which we've created and we can return. But if we have a head, then in that case, what I can do is I can say new node dot next would be equal to self dot head. So let's see if I have a node 10, which is the only node in my linked list, then what I'm doing is I'm creating this new node and I'm pointing this to head. So which would mean that this new node would be on the left side of head and this would be our head. So to make this the head, I'll point self dot head to the new node which I've just created. So this is the process. First, take the new node, point it to the head, then take the head pointer and point it to the new node which you've just created. So this is the insert at head method. Going ahead, I would also want to insert something at the tail of this linked list. So I'll say self x. Again, I shall create a new node over here. And this will be from the list node class which we've created. Again, I do want to check if head is none. So if self.head is equal to none, then I can just point head to the new node which we've just created. But if that is not the case, again, I'll create a temporary node called as temp, and initially this will point to whatever head is pointing to. So temp is equal to self.head, and then going ahead, what I'd want to do is I would want to travel throughout this list and go to the tail. So while temp dot next is not equal to none. So again, 10, 20, and 30, I'll reach 30, and 30's next would be equal to none. So my temp would be pointing to 30. So while temp dot next is not equal to none, I'll say temp is equal to temp dot next. So I have created this, and once I'm out of this loop, I can just go ahead and point temps next to the new node which we have created at the top. So 10, 20, 30, let's say this is 40. Since temp is pointing to 30, what I'll do is 30's next, I'm making it point to the new node. So 30 will point to 40. So we've created all of these methods over here. Now, let's go ahead and create an instance for our linked list. So I'll say ll is equal to linked list. We've created an instance of this. Now, let me insert something at the head of it. So ll dot insert 10. Similarly, let me copy this and let me again paste something at the head. ll dot insert at head 20. Now I'd want to traverse this. ll.traverse, you'll see initially at the head we had 10 and at the head we had 20. So 10, 20, now 20 is pointing to 10. That is why 20 is at the head. So when we traverse, we first come to 20 and then we'll go to 10. Now let's insert something at the end. So I'll say ll.insert at tail and I'll insert 40 and I'll also insert 50. And now what I want to do is again traverse this and let's see what would be the result. You see, so we've inserted 40 and 50 at the tail. So 20, 10, 40 and 50. So this is how a linked list works. So thank you very much. Hopefully you found this session informative. So do like the video and also subscribe to our channel. Thank you very much and I'll meet you in the next one.